is question 35 from the GATE 2019 EE paper, where we are given a 4-variable K-map and are asked to find out what the output expression is after logic simplification. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic.
So this is a 4-variable K-map with the variables being PQ and RS respectively, and the values of PQ given in gray code are on the top edge of the K-map and the values for RS are on the left edge. So the idea is to group maximally in powers of 2 neighboring ones, right? So it's either 2 ones or 4 ones or 8 ones and so forth, and they have to be neighboring. That is, the value of PQ and RS that they represent should be different by a Hamming distance only of 1. For example, I can group these two together because this is for a PQRS of 0, 1, 0, 0, because that is the cell that this represents, right? So this is for PQRS equal to 0, 1, 0, 0, and this is for PQRS equal to, so RS doesn't change because it's on the same row. PQ is 1, 1. So you can see that only one bit is different, and so the Hamming distance is 1. So the idea is, if I take any two ones that are adjacent to each other, they should have a Hamming distance of 1 in the grouping that I make. So I can group the ones like so. I can group the ones like so, right? And I can't group the ones like that because you have to group ones in powers of 2. So I can group the ones like so, and I can group ones like so. The idea is that any two ones that are adjacent to each other, adjacent as in to the bottom, left, top or right, not diagonal. These two are not adjacent, right? If you take any two ones in this grouping that are adjacent to each other, the Hamming distance between the binary, the 4-bit number that represents the two cells, will be equal to 1. Now to find out what this grouping represents as a logic simplification, right? So what's common between these two cells is 1 and 1. So that is in the position corresponding to Q, and since that's a 1, I put a Q here. And what's common between these two cells, right, that correspond to these two rows of the grouping, is 0 and 0 in the position that corresponds to R. So that's 0, and since this is a K-map of minterms, that is, we are grouping ones, 0 corresponds to R bar and 1 corresponds to Q. So that's R bar Q, and similarly this will correspond to S because this is 1, 1 in the position corresponding to R. So it's S, and since we have grouped everything here, we have eliminated both P and Q, right? So this is, so there are two two covers here, that is, there are two groupings of ones, each one rendering a product term, right? So that gives the following sum of products logic simplified expression as S plus R bar Q, right? You can see in the solution it's S plus R bar Q, and the answer is A.